Welcome back to part 2 of module 4, lesson 4, find the percent of a number. This next problem is very similar to the last one we did in part 1, only now it is going to be your turn to find out how many students bring snacks. Pause the video, do this problem, see what you get for an answer. Did you solve it? Let's take a look at how I do it. So we're looking for chips, and chips are 18%. Now, keeping in mind how the problem was done last time, if we were to take 18% of 100, that would mean that each group of 100 is going to be 18 students, right? But we don't have just one group of 100, we have 3 groups of 100. So your textbook said, well, from there you do 3 times your 18 to find out that's going to be 30 plus 24. That should be 54 students are going to prefer chips for their snack. Now, that is a way of doing it, and your textbook says it's a good way of showing your work. But this is how I would do it. If it was me doing the problem, I would say I have 18 over 100 students. My goal is to get to 300 students, so I'd say 100 times what? 3 is equal to 300, and then I say 18 times the same 3 is going to give me the 54, and therefore I'm going to have 54 students who prefer to eat chips. 2 different ways to solve the problem. Both of them are perfectly legitimate. Either way, let's go back, plug our answer in, say 54 students, and check our answer, and we are winning again. Love it when a plan comes together. Now let's look at a new problem. This one's going to be a little bit more challenging. What is 30% of 240? Is 30% of 240 going to be less than or greater than 120? How would you know? Well, let's see. 120 is half of 240, which means it's 50% of 240. 30% is less than 50%, so 30% will be less than 120. Let's keep moving. So, what is the part going to be? The part is going to be, we don't know that. That's what we're looking for. The whole, however, is going to be the 240. And the percent we're looking at, that is going to be the 30. With that information, we can proceed to actually solving this problem once we recognize what we're working with. Now, they've got several ways you can work it. The method 1 is going to be to use the bar diagram. In the bar diagram, you can see they have 0 to 100%. All right, they broke that down into 10 sections, and conveniently enough, the 240 divided perfectly by 10. Anytime you have a 0 on the end, you know it's going to divide perfectly by 10, so each one of these sections has 24 in it. From there, we can take and say, well, 24 plus 24 plus 24, that's going to be 72 for your answer. Another way that you could look at it is to take and use your double number line. Once again, on your double number line, your percent is set up along the bottom, 0 to 100%. We're going to take, the tick mark that corresponds with 100% on the bottom will have a value of what? That is going to be 240, because 100% of the people is going to be 240. That one checked. So that means that we're going to put a 240 right here above the 100%. Now, since there's 10 increments, the value of each tick mark is going to be what? Well, 240 divided by 10, that's going to be the 24 we found when using the bar diagram. So we know that each one of these is going to increase by 24. And then moving forward from there, you can see how that worked. 0, 24, 48, 72, 96, and so on. And the number that on the number line that occurs with 30%, boom, right there is going to be 72, and check your answers. You got the same exact answer this way that we got using the bar diagram. But that's not the only way to solve these. We could also use equivalent ratios. And if it was me doing it, this is what I would do. Now I'm going to take and pause it while I get a screenshot so I can show you how I would do this particular work. Now once again, the problem is set up where you have your percents over on the left hand side. We're looking at 30% to 100. Let's see if I can get my cursor to work. 30% out of 100%. So 30% is my part, 100% is my whole. On the left hand side, my whole is 240. That's all the numbers. My part, that's what we're looking for. Now using the technique that they taught us, we would say, well, alright, let's get my marker going here. 100 times what number is equal to 240? And they're going from 100 to 240. What do we multiply by? The answer is really obvious if you think about it, but if you don't think, it can be kind of tricky. It's going to be 2.4, because 100 times 2 is 200, and 100 times 0.4 is going to be 40. From there, we can say that if 100 times 2.4 is 240, then we're going to be using 30 times the same 2.4, and when we do that, we're going to get the same 72. How did I get that answer? 22.4 times 30, 0 times 4 is 0, 0 times 2 is 0, 3 times 4 is 12, 3 times 2 is 6, plus 1 from the 12 is 7. Add those up. Whoops, I put two wrong numbers backwards there. Bounce, bounce, and that is where the 72 came from. Now, if you look at the problem they gave us, you can see they said that, but they kind of threw it all at you. I wanted to explain it a little bit better. So, what is our answer going to be? It's still going to be the same 72 we found the other two ways. Now it's going to be your turn to solve this problem. Which method are you going to use? Are you going to use a bar diagram? Are you going to use a double line plot? Or are you going to use algebra with equivalent ratios? Pause the recording, solve the problem. Personally, I think using the bar diagram or the double line plot would be a really bad idea on this one. The reason being is this number right here. I can't really divide 315 into 10 even numbers or anything else that would really work very nicely with breaking down from 100%. I could divide top and bottom by 5, but if I did that, I'd have to do 20 sections, and I don't really want to do 20 sections when it'd be so much easier to just use math. So we know that my whole amount is going to be 350. The part we're looking for, and we know that we have 60 out of 100. 60% out of 100 is how many out of 350. So once again, we ask ourselves, what do you have to do to 100 to get to 315? That is going to be to multiply it, oops, put that in the wrong spot, to multiply it by 3.15. And when you do, you get the 315. With that said, we have to do the same thing on the bottom. 60 times the same 3.15, and now I'm going to have to do some grunt work. So 3.15 times 60, 0 times 5, 0 times 1, and 0 times 3. That part was easy. 6 times 5 is 30. 6 times 1 is 6, plus a 3 from the 30 is going to be 9. And then 6 times 3, that's going to be 18. Add them up, 0, 0, 9, 8, 1, bounce, 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 bounce. Answer is going to be n is equal to 189. Circle our answers, and let's go back and plug it in and see if we are right. 60% of 315, 189. Check our answer. Woohoo! We got it right. Now, so far, we've looked at some great ways of solving these problems, but everything we have done is just a repeat of what we did in Module 1. Wouldn't it be cool if they would teach us something new? I think so. Let's take a look. So, moving up from here, we've got to drag our problems here, and let's see if it'll work. So, first off, our part is going to be, I need to read the problem, 145% of 300. All right, so the whole is going to be my 300. My percent is 145. My part is going to be in. Check that answer. That one checked good. Let's see here. Are we going to get something new? No, but we're going to use something old. We have the ratio table going here. And for our ratio table, they put the percent over the part, and you had 100% over the 320 that was total. Now the goal is to get to 145, and 145% is going to be here. I can't multiply 100 by any whole numbers to get to 145, so we want to take and find something we can divide the top and the bottom by that would give us a percent that I could then multiply to 145. So what are we going to use here? Well, let's try 100. I wouldn't have done 100. I would have done 5. But they said to do 100, so let's do 100, and I'll show you what 5 would look like in a minute here. So they divide top and bottom by 100, made it pretty easy for that part of it. 100 divided by 100 is 1. 320 divided by 100 is 3.2. Now, what do you have to do to 1 to get it equal to 100? Well, you have to, to get it equal to 145, you have to multiply by 145. And if you do it on the top, you have to do it on the bottom, and that's going to end up giving me the 464 for the answer. Let's take a look at how I would have done this problem, though. Now, if it was me doing this problem, I would have worked it in such a way so that my percent ended up being 5. So I would have said 100 divided by 20 is equal to 5, and I can easily divide 320 by 20, and that's going to end up giving me 1516. So now I'm off to a good start. But I don't want 5%, I want 145%. So to get from 5 to 145, I have to multiply 5 by, let's see here, that answer is going to be 29. So I'm going to do times 29 on the top. Therefore, I also have to do times 29 on the bottom. And when you multiply 29 times 60, you end up getting the same exact answer that they got, 464. But I'm not going to waste your time doing that grunt work. To solve the same problem using equivalent ratios, let's take a look at this one. So they set us up with a problem here, and in our problem we have got 145% compared to 100%, the unknown part compared to the whole part of 320. So ask yourself, what do you have to do from 100 to get it to 320? That's me multiply it by 3.2. So from there we could say right here 100 times 3.2 is equal to 320. Therefore, 145 times 3.2 is going to give us our answer, which is going to be the same 464 that we have seen the other ways we've done it. So n is now equal to 464. Once again, go back to our book and we can put in the same 464 right there. Lots of different ways to skin this cat. Now let's compare the part 464 to the whole 320. Does it make sense for a part to be bigger than a whole? In this case, yes, because we went to a number greater than 100% of the whole. We went to 145% of the whole, therefore the part has to be bigger than the whole number was. Now it is time for you to pause the recording, solve this problem. You can use any of the techniques that you want to use. Did you get it done? Let's look at how I would do it. I'm going to use the algebraic method, the equivalent ratios, because that's just kind of what I like. I know my part is what I'm looking for. I know that my whole is going to be 65, and I know that I have 220%, and a percent is a ratio compared to 100. So 65 is the 100% of the starting amount. Now we need 220%. We have to ask ourselves, what do we do to 100 to get it to equal to 65? Well, now therein lies the challenge, doesn't it? I think we need to use a different way. Instead of doing this method, because there's no number I can divide 100 by to get, no whole number to get to 65, I think that we would be better off to use the table approach. Even though I like the algebraic approach, let's use the table approach instead. So we're going to start off with the part and the whole. From here, I'm going to have three groups. One group is going to say that I've got to get to 65. I know that I have 220 is going to be my part compared to the 100 is going to be my whole. And now I'm going to take and divide this down into something that I can multiply to get to 65. And my answer is going to be to divide the top and bottom by 20. 100 divided by 20 is going to be 5. 220 divided by 20, well, that is going to be 11. Now I'm going to say 5 times what number is 65. So from there, not going to be 5. 5 times what is 65? That is going to be 13. So I've got to do the same thing on the top. Let me erase this other mess that I didn't need up here. So all that we're going to get rid of, so I have room to write where I have taken and multiplied by the same 13 on the top, and 11 times 13 is going to be 100, nope, not 20, 143. And by the way, there's a really cool trick for multiplying by 13, multiplying by 11, put my 143 there. You can multiply any number by 11 by writing your first number, 1, writing your last number, 3, and then adding your first and the last number. 1 and 3 is 4, and that is how I did the math to get my answer of 143. Now we're going to go back to the problem. We're going to type in our 143. We're going to check it, and ding. Even though I like the equivalent ratio method better, sometimes it's not the best choice. I started that way. I realized, that's not what I needed. I changed and went to something that worked better. Now that is going to be it for part 2. Make sure you come back to watch part 3 so that you can learn everything you need to know about how to find the percent of a number.